Let's try one last one like this. Looking at this next one, we're going to start with, let's see, f of -1. And again, we'll switch the notation and use our parentheses instead. This will give us f of -1. So we'll start in the innermost, which is just a regular f of -1, which means that we're going to plug in a -1 wherever there's an x into our f of x function. Well, our f of x function was, remember, x squared plus 3x. So that means I'll have a -1 squared plus 3 times -1. So we have to follow order of operations first. So the first thing that we'd end up doing is the -1 squared, which is +1. And then we would end up doing the 3 times -1, which is -3. And as a quick reminder, we are adding, so that will get us a -2. So what that means is when we plug in an x value of -1 to f, we get out a -2. So that means I can replace this entire f of -1 with a -2, because that's what we got out. However, we still have another f that was out in front that we haven't dealt with. So now what this means is now I need to take the -2 I got out and plug it back in to f. That's what this is saying. So as a reminder, our f function looks like something squared. Well, what we're plugging in for x is a -2. So that'll get squared plus 3 times x, which is again -2. So we'll do our order of operations doing our exponents first, which is the -2 squared, which is a +4. And we'll also go after the 3 times -2, which is -6. We are adding, so a 4 plus a -6 is -2. So f of -1 gets us out a value of -2, and that's our final answer. Now let's take a look at a different example. On this next one, what we're going to use is we're going to use a picture to do the same type of problem. So let's take a look. On problem A. On problem A, let's see, we've got f. We'll switch up g of 2. We'll switch the notation and use parentheses instead. So that means we'll be looking at f of g of 2. Remember, we're using pictures now, so we need to be a tiny bit careful. So let's start out with finding out what is g of 2. Well, g of 2 means we're going to look at our pink graph and go to 2, and we're going to look for the point there. And we're going to figure out what you actually get out there. So if I go to G and I look for G of 2, here it is. Well, notice then what I get out is a value of -2 for my Y. So that means G of 2, when I plug in 2, I get out -2. Be careful, I'm still not done because I haven't dealt with the f that's out in front. Now I'm supposed to take this value -2 and take it and plug it back into f. Sorry, this value -2 and plug it back into f. So let's go look at our picture. Our blue line is the graph of f. So now I'm going to go look at f and look for the value -2, which is over here. So on my blue graph, my graph at -2 is out here at -4. So what that means is then I get out a final answer of -4 when I plug in my value into f. So my answer for this full thing, when I were to plug it into my math lab, would just be the number -4. Now let's take a look at B. In B, we've got g of f of 4. So let's use, again, parentheses and swap out the notation here. So that will look like now g of f of 4. So we'll start with the innermost part. We'll start out with f of 4 meaning I'm going to go look at my pink graph and see where, if I plug in 4 for x, what I get out for y, and that's this point up here. So when I plug in 4 for x, I get out a 2 for y, so that means f of 4 is 2. Be careful, I still have not dealt with g, so whatever I'm getting out, I'm going to have to turn around and plug into g. So let's take a look, and I'm going to use a different color this time. So now we're looking to find g of 2. G is the blue graph, so that means I'm going to go look for 2 on my blue graph. Well, here's my point on my blue graph at 2, which says that if I plug in 2 to g, I get out 0 for y. And so that's going to be our final answer for this one. When you plug in a 2 to g, you're going to get out 0, and we're done. Let's take a look at another problem. In problem 2, notice we've got f of g of negative 2. We've got 2 different graphs to look at. We'll change our notation to parentheses. And so what we're looking at is f of g of negative 2. So we'll start off by trying to find g of negative 2, which means if I plug in negative 2 to g, which is our pink graph, what do I get out for y? Well, then I'm up here, and when I plug in negative 2 for x, I'm getting out 4 for y. So g of negative 2 is 4. I still have to deal with f. I have to take this answer and plug it back into f. Well, that is going to be my blue graph, so I need to turn around and take my 4 that I just got out and plug it into my blue graph, which will put me up at this point, which comes out at 2. So I will get out my final answer of 2, and I'll be done. That would be what I would enter into my math lab. Let's try one more. Let's take a look at the next one and switch the notation first to parentheses. So what that will now give me is g of f of 1. And we'll start off by looking at f of 1, and that's our blue graph. So we're looking at, let's see, plugging in 1 to our blue graph and seeing where our function is. Well, plugging in 1 on our blue graph puts us at this point, which actually is the 0.11, so that means if I plug in 1 to f, I get out another 1. However, I'm not done. I still have to deal with g here. So that means I'm going to take this 1 I got out and plug it back into g. So let's take that 1 and plug it back into g. And let's see what happens. So we'll take our 1, plug it back into g. And let's see. Well, plugging our 1 back into g, notice g also goes through that point too. 1, 1. So that means when we plug in 1 to g, we're still going to get out another 1. It's kind of like we're stuck at that point. So our final answer is just the number 1. We're just kind of stuck at that one point that we keep on hitting over and over and over again. Let's try one last one. Let's switch out the notation first and use parentheses. So what we've got is f of 0. So we'll start out with the inside portion. We're going to use the same picture and start with f of 0. So let's try that first. Let's see what color we're going to use. Let's use something different. Let's use green. F of 0. So let's go to our picture, and we're going to go look at our f graph, which happens to be the blue graph, and we're going to try and find f of 0, which is actually down here at 0. It's at the origin. So f of 0 is 0. Now I still have to take that and plug that back into f. So that's asking us to find f of 0 again. Well, that means we're still on that origin point. So if I plug in 0 again, it's not going to change. I'm still going to get 0 out. So it's kind of like I'm again stuck at the same point. I plug in 0, I get out 0. I plug it back in, I still get out 0. And that's my final answer, is just 0. In this next problem, it's more of a thought-provoking problem. They want you to find f of g of x and g of f of x and compare the two. That's all they really want you to do. So let's go ahead and try that. So once again, let's switch the notation to parentheses on both of these. So on the first one, we're going to be looking at, let's see, f of g of x. And we'll start out with the g of x function, which is x cubed plus 3, and we'll replace that. So we'll leave the f out in front, we'll leave the parentheses, we're just swapping out the g of x, which is x cubed plus 3. Now what this is now telling me to do is to go into f, and wherever there's an x, to plug in this x plus 3. So I'm going into my f function, and wherever there's an x, I'm replacing it with the x cubed plus 3. So what this will look like is our cube root, then our x will get replaced with x cubed plus 3, and then after that, we had a normal minus 3 in there. Well, notice what will happen first is we've got this plus 3, and we've also got a minus 3 in here. What will happen is those are opposites, so they'll just cancel out. That leaves us with, we've still got a cube root, and we've still got an x cubed inside. What's awesome here is we've got a cube root and a cube. They're opposites. They will also cancel out. But that still leaves you with that x that was underneath. So our final answer for f of g of x is just an x. Now let's see what's going on in the other one. So in the other one, we've got g of f of x, and we'll start out with the f of x this time, and replace that first, leaving the g by itself also. So the f of x is the cube root of x minus 3, and now in this one, what they want us to do is to take this inside part, the cube root of x minus 3, and plug it into g now wherever there's an x. So let's go ahead and do that. Well, the first thing you see in the g function is the x, and we're replacing that with the cube root of x minus 3. Then notice that entire piece, that's your x, should get cubed and have a plus 3 after. Now, just like the last one, we've got a cube root and a cube right on top of one another. That means those two will cancel out, leaving you with what was underneath, the x minus 3, but you also had the plus 3 on the outside. So what's going to happen is that minus 3 and that plus 3 are opposites. Those two will also cancel out, leaving you with just an x. Notice they asked this question at the beginning. They asked, do both of them equal just an x? And the answer to that question now, we just found they do both equal x, is a big yes. The question is, what does that mean? What this means is that both of the functions undid one another completely and just left each other with an x. You learn about this back in college algebra. You learn that if two functions do this to one another, when you plug them into one another, that they completely undo one another, leaving you with just an x. That means that those two functions are called inverses. So the two functions are inverses. They undo one another because both one f of g of x cancels out, they cancel out each other and just leave you with an x. And it's the big key here. g of f of x also cancel each other out and gives you an x. That's what it means for two functions to be inverses. It has to do this on both of them, not just one. It's that when you plug in g to f, it cancels it out and leaves you with just an x. And when you plug in f to g, they cancel one another out and leave you with just an x. It has to work in both directions.